I is equal to 1, 0, 0, 1, show that A into I is equal to I into A is equal to A. Any matrix into identity matrix or identity matrix into any matrix is equal to the same matrix. X is to be determined such that the given condition, an equation is given 2A plus X is equal to 3B. So, therefore, A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. Hello, welcome to this session of a mathematics class. I am Mr. Niranjan, faculty in mathematics, Vidhyaashram PU College. Now, in this session, I am going to discuss regarding some miscellaneous additional miscellaneous problems. So far, we have studied the types of matrices, operations on matrices like addition, subtraction, multiplication, division, then scalar multiplication, matrix multiplication, and properties like symmetric and skew symmetric, transpose of matrices, and problems based on all those we have studied so far. Now, in this final session, let us discuss something which are in miscellaneous concepts. Now, let us take the first problem here. So, the problem is if A is equal to 1, minus 1, 2, 3 and I is equal to 1, 0, 0, 1, show that A into I is equal to I into A is equal to A. So, the same property we have used for problem solving in elementary row operations to find the inverse of a matrix. And also in theorems we have used this concept, A matrix into identity matrix is equal to identity matrix into any matrix is equal to same matrix. Now, that is a problem. Now, let us verify this matrix. Now, what is given? A and I is given. Now, find out A, I first. A into I. 1, minus 1, 2 and 3. 1, 0, 0, 1. Now, this is first row, first column, second column. Now, this is equal to multiplication. So, if you have any doubt in multiplication, observe carefully. So, let us take first row, first column, 1 into 1. 1 into 1 is 1. Again, minus 1 into 0 is equal to 0. First row, first column finished. Second row, second column, first row, second column, 1 into 0 is 0. Minus 1 into 1 is minus 1. First row, first column, second column. Next, again, second row, first column, second column. 2 into 1 is 2, plus 3 into 0 is equal to 0. Again, same row, second column, 2 into 0 is equal to 0. Again, plus 3 into 1 is equal to 3. Now, this is equal to 1 minus 0 is 1, 0 minus 1 is minus 1, 2 plus 0 is equal to 2, 0 plus 3 is equal to 3. That is 1 minus 1, 2. This is equal to the same matrix, your A. So, if I multiply any matrix with an identity matrix, I will get the same matrix. Similarly, on the other hand, let us find out this I into A. What is I? 1, 0, 0, 1 into A. What is A? 1 minus 1, 1 minus 1, 2 and 3. Now, same first row, first column, second column. This is equal to 1 into 1 is 1 plus 0 into 2 is equal to 0. 1 into minus 1 is minus 1 plus 0 into 3 is equal to 0. Again, second row, first column, 0 into 1 is 0 plus 1 into 2 is 2. Again, 0 into minus 1 is 0 plus 1 into 3 is equal to 3. So, that is equal to 1, minus 1, 2 and 3. What is this equal to? So, from 1 and 2, if LHS is equal means definitely RHS is also equal. So, therefore, from 1 and 2, what do you say? Any matrix into identity matrix or identity matrix into any matrix is equal to the same matrix. So, this is the property we have used to solve the problems in elementary row operation, transformation, to find the inverse. Now, let us come to a second problem, second type of problem. Now, let us consider this problem. This is also very important for 3 marks. Sometimes they may ask for 5 marks. What is the question here? Find x if x minus 5 minus 1, a matrix of order 1 into 3, 1 row, 3 columns, another matrix of order 3 rows, 3 columns, 1 0 2, 0 2 1, 2 0 3, and x 4 1, a matrix of order 3 rows and one column is given, that is equal to 0. So then find the value of x here. So let us multiply these two first, then multiply with this, otherwise multiply these two and multiply with that. So let us multiply these two. I will keep this as it is, x minus 5 minus 1, and let us multiply these two. So check whether it is possible to multiply or not. Since this 3 and 3 are equal, so you can multiply. The matrix you are going to get is of order 3 rows and 1 column. So 3 rows and 1 column is, usually you will get a matrix like this. Now multiply, only one first row, 1 column is there. 1 into x is x, 0 into 4 is 0, 0, again plus 2 into 1 is equal to 2. First row. Again second row, for second row, first column, 0 into x, 0 into x is equal to 0, plus 2 into 4 is 8, plus 1 into 4 is equal to 1 into 1 is equal to 1. Second row. Next, third row, first column, 2 into x is equal to 2x, plus 0 into 4 is 0, plus 1 into 3 is equal to 3. This is equal to 0. Now that is x minus 5 minus 1. Simplify this. X plus 2, 8 plus 1 is 9, 2x plus 3. This is equal to 0. So the order for this is 1, 2, 3, 3 rows, 1 column. This is 1 row, 3 column. These 3 are equal, 3 and 3 order is same. So if you simplify, you will get a matrix. You are going to get a matrix of order 1 into 1, 1 row, 1 column. Now let us simplify this. So first row, first column. So that is x into x plus 2 plus this minus 5 into 9 plus minus 1 into 2x plus 3. This is equal to 0. Now simplify this. So this is x into x is x square plus 2x minus 9 into 5, 45, minus 2 into x is minus 2x, minus into plus it is minus 3 is equal to 0. So totally you are going to get a matrix. So here plus 2x and minus 2x gets cancelled. X square minus 45 minus 3, minus 45 minus 40 minus 3 is minus 48 is equal to 0. So x square minus 48 is equal to 0, a quadratic equation. This can be solved. X square is equal to 48, x is equal to plus or minus root of 48. So the value of x is equal to plus or minus root 48. So here very simple, this type of questions they may ask for 5 marks also. Very easy. First multiply these to check the order. So this is possible to multiply or not. So since this is 3 rows 3 column, 3 rows 1 column, you can multiply, and the matrix we are going to get is 3 rows into 1 column. So 1 into x is x, 0 into 4 is 0, 2 into 1 is 2, again 0 into x is 0, 2 into 4 is 8, plus 1 ones are 1, 2 into x is 2x, plus 0 into 4 is 0, 3 into 1 is 3, add x plus 2, 8 plus 1 is 9, 2x plus 3, this is same, again this is 1 row 3 column, this is 3 rows 1 column. You can multiply this matrix. First row, first column, x into x plus 2 plus minus 5 into 9 plus minus 1 into 2x plus 3. So multiply this, x into x is x square, 2 into x is 2x, minus 9 5s are 45, minus 2 into x is 2x, minus into plus minus 3, plus 2x minus 2x gets cancelled. So x square minus 45 minus 3 is minus 48, x square is equal to 48. Therefore, x square is equal to 48 means x is equal to square root of 48 plus or minus root 48. Now let us come to the same type problem. One more problem is there. We will solve the same type problem. Same type problem. Find x if 1 2 1, 1 2 0, 2 0 1, 1 0 2, 0 2 0 is equal to x. Find x. Same. Let us write down the order for this. This is 1 row 3 column. This is 3 rows 3 column. This is 3 rows 1 column. Now let us verify these two are equal. So we can multiply a matrix and which we are going to get is of order 3 cross 1. This is same 1 2 1 as it is. Multiply this. So first row, first column, 1 into 0, 0, 2 into 2 is 4, again 0 into x is 0. Second row, first column, 2 into 0, 0, plus 0 into 2 is 0, plus 1 into x is x. Again third row, this column, 1 into 0, 0, plus 0, plus 2 into x is equal to 2x, and this is same, this is equal to 0. Now this is 1, 2, 1, add 4, 0 plus x is x, and this is 2x. Now what is the order? Here the order for this is 1 cross 3, this is 3 cross 1. So since these two are equal, you can multiply and you are going to get a matrix of order 1 into 1. So first row, again first column, 1 into 4, 1 into 4 plus 2 into x, 2 into x plus 1 into 2x is equal to 0. So that is 4 ones are 4 plus 2 into x is 2x plus 2x is equal to 0. This is 4 plus 4x is equal to 0. Now, since this is 4 plus 4x is equal to 0 or 4x is equal to minus 4, x is equal to minus 4 by 4 is equal to, so therefore x is equal to minus 1 is the simplified answer for this matrix. So x is equal to minus 1. So the answer for this is x is equal to minus 1 is the correct answer. X is equal to minus 1. So this is also a very important problem. Now next, let us come to the next problem. So what is given? You may get this type of questions for 3 marks. If A is equal to 1, minus 1, 2, 3, B is equal to 2, 1, 0, 1, find a matrix X, X is to be determined such that the given condition, an equation is given 2A plus X is equal to 3B. What is given? The given equation is 2 into 2A plus matrix X is equal to 3B. Now what is required to find is matrix X? So you just keep X and transfer this. This becomes plus 3B minus 2A. That's all. Now this is 3 into B. What is B? 2, 1, 0, 1 minus 2 into A. 1, minus 1, 2 and 3. So that is equal to 3 2s are 6, 3 1s are 3, 3 into 0 is 0, 3 1s are 3. Scalar multiplication minus 2 into 1 is 2, minus 2, 4 and 3 2s are 6. Subtract this, this is equal to 6 minus 2 is 4. Again 3 minus into minus is plus, 3 minus of minus, that is 3 plus 2. 3 plus 2 is equal to 5. This is 5. Next 0 minus 4 is equal to minus 4 and 3 minus 6. 3 minus 6 is equal to minus 3. This is minus 3. So therefore the matrix X is equal to, what is the matrix? 4, 5, minus 4 and minus 3. This is also of same order 2 cross 2. So this is the value of X. Check. So what is given equation? 2A plus X is equal to 3B. X is equal to 3B minus 2A. 3 into B. 2, 1, 0, 1 minus 2 into A. 1 minus 1, 2. 3 2s are 6. 3 1s are 3. 3 into 0, 0. 3 1s are 3. 2 1s are 2. 2 into minus 1 is minus 2. 2 into 2 is 4. 2 into 3 is 6. Subtract this. 6 minus 4 is 6 minus 2 is 4. 3 minus of minus is plus, 3 plus 2 is 5. 0 minus 4 is minus 4. 3 minus 6 is equal to minus 3. Therefore, X is equal to 4, 5, minus 4, minus 3 is the simplified answer. Right. Next, coming to the next problem. What is the problem? If A dash is equal to minus 2, 3, 1, 2 and B is equal to minus 1, 0, 1, 2. Find A plus 2B whole dash, the transpose. See, check here. What is given? A dash is given, not A. A dash is given. Now, if A dash is given, therefore A is equal to, the transpose of this matrix is A. The transpose this. So, A dash is this. Therefore, A is equal to minus 2, 3, 1 and 2. See, if you transpose this, if you transpose, first row becomes first column, second row becomes second column, then you will get the matrix A dash. So what is required to find is to find A plus 2B. First find out A plus 2B. What is A? A is equal to this one, minus 2, 1, 3, 2 plus 2 into B. What is B? Straight away you can write B. 1, minus 1, 0, 1 and 2. So that is equal to minus 2, this is plus 1, 3 and 2 plus 2 into minus 1 is minus 2, 0, then 2 into 1 is 2, 2 into 2 is equal to 4. Add this, if you add, that is minus 2, 1 plus 0, 3 plus 2, again 2 plus 4, that is equal to, this is equal to, minus 2 is minus 4, 1 plus 0 is 1, again 3 plus 2 is equal to 5, 2 plus 4 is equal to 6. This is A plus 2B. Now A plus 2B matrix is equal to minus 4, 1, 5 it is. Now therefore the transpose of this A plus 2B whole dash, transpose this, first row becomes first column and second row becomes second column. Transpose of this is minus 4, first row becomes first column and second row that becomes second column. This is the value of A plus 2B. Okay, this is also important for 2 marks. Sometimes they may ask this type of questions for 2 marks. Now let us come to the next problem, question number 6. Now this we have verified while doing the problems in symmetric and skew symmetric. Expressing any square matrix as a sum of a symmetric and skew symmetric, we are using the same property. Now what is the question given here? If for the matrix A 1, 5, 6, 7, verify that A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. First find out A dash. What is A dash? The transpose of A. First row becomes first column, 1, 5, 6, 7. Now first find out A plus A dash. What is A here? 1, 5, 6, 7 plus the transpose of this is 1, 5, 6, 7. Add this. So corresponding elements 1 plus 1, again 5 plus 6, again 6 plus 5, again 7 plus 7. Now that is equal to 2, 5 plus this is 11, again this is 11 and 14. So here see all the elements above the principal diagonal are same. Further if you transpose this, A dash is equal to A, so therefore this is a symmetric matrix. So A plus A dash is a symmetric matrix. Now let us come to the second part, A minus A dash. Now A minus A dash, A minus A dash. What is A? A is equal to 1, 5, 6, 7 minus the transpose of this 1, 5, 6, 7. So that is equal to, subtract this, 1 minus 1, 0, 5 minus 6 is minus 1, 6 minus 5 is plus 1, 7 minus 7. So this is a skew symmetric matrix, skew symmetric matrix. So all the elements in the principal diagonal are 0 and this will have the opposite sign. So that is, if you transpose this, you will get negative matrix. So therefore this is a skew symmetric. So A dash is equal to minus A you will get. So therefore A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. Now come to the next problem. So here this is very important problem. Sometimes they may ask this for a CET also. What is the problem given? If A is equal to cos alpha minus sin alpha cos alpha, and the given condition is A plus A dash. If you add A and the transpose, you will get an identity matrix. If such is the case, then the value of alpha is, then the value of alpha, the angle is to be determined. Now first given equation is A plus A dash is equal to I. What is A here? A is cos alpha minus sin alpha cos alpha. Okay, plus the transpose of this, transpose this, cos first row becomes first column, cos alpha minus sin alpha and sin alpha into cos alpha. This is equal to I, identity matrix of same order means 1 0 0 1, that you should have to put. Now add this. So if add addition cos alpha plus cos alpha, again minus sin alpha plus sin alpha, cos alpha, this is sin alpha, plus into minus minus sin alpha, again cos alpha plus cos alpha. So this is equal to this matrix. Cos alpha plus cos alpha is 2 times cos alpha, minus sin alpha plus sin alpha gets cancelled 0, minus sin alpha plus sin alpha gets cancelled 0. Cos alpha plus cos alpha is equal to 2 times cos alpha. This is equal to 1, 0, 0, 1. Now, equate this here. 2 cos alpha is equal to 1. 0 is equal to 0. 0 is equal to 0. Again 2 cos alpha is equal to 1. By equality of matrices, you can write 2 cos alpha is equal to 1. So, therefore, cos alpha is equal to 1 by 2. So, cos alpha is equal to 1 by 2 means, so for what value of alpha you are going to get 1 by 2 in cos. So, this is nothing but, so you know this, sin 30 degrees, sin 30 1 by 2, then sin 60 is equal to root 3 by 2, and cos 60 is equal to 1 by 2. So, here for cos of 60 degree can be written as pi by 3 radians. So, therefore, alpha is equal to pi by 3 radians, that is pi divided by 3 radians or 60 degrees. For alpha is equal to pi by 3 or 60 degree, the given equation cos alpha minus sin alpha cos alpha will satisfy a plus a dash is equal to I. This is very important problem for 3 marks. Now, let us come to the next type of problem. What is the problem given? If a is equal to 3, 1, minus 1, 2, prove that a square minus 5a plus 7i is equal to 0, where I is an identity matrix of same order. This type of problems we did in previous classes for finding the inverse, Cayley-Hamilton theorem actually it is. Now, see, there are 2 methods in this, don't get confused. So, in the examination they may ask, so if you prove that means you should have to verify this equation, okay. Otherwise, they may ask if a is equal to 3, 1, minus 1, 2, satisfies the equation a square minus 5a plus 7i is equal to 0, where I is an identity matrix of same order, then find A inverse means that which we did in the previous classes. The method is different. Now, let us solve this first. Now, a square minus 5a plus 7i is equal to 0. Now, first find out a square. A square means a into a. 3, 1, minus 1, 2. Again, 3, 1, minus 1, 2. Multiplication, first row, first column, second column. 3 3s are 9. 1 into minus 1 is minus 1. 1 3s are 3. 1 into 2 is 2. Again, minus 1 into 3 is minus 3. 2 into 1 is minus 2. Second row, first column, second column, minus 1 into 1 is minus 1, plus 2 into 2 is 4. This is equal to 8, 5, minus 5 and 3. This is the value of a square. Now come to this equation. Straight away come to this equation. Now, what is to verify is a square minus 5a plus 7i is a null matrix is equal to 0. Now, this is equal to, what is a square? 8, 5, minus 5, 3, minus 5 into a. What is a? The given matrix. 3, 1, minus 1, 2, plus 7 into I, you know, 1, 0, 0, 1 is the identity matrix here. So, this is equal to 8, 5, minus 5, 3, multiply by 5, 5 3s are 15, 5 1s are 5, minus 5, 5 2s are 10, multiply by 7, 7, 0, 0, 7. Subtract this, 8 minus 15 is minus 7, 5 minus 5 is 0, minus into minus plus here, minus 5 this is minus 5, minus into minus is plus, this is equal to 0, 3 minus 10 is equal to minus 7, plus 7, 0, 0, 7. This is minus 7. Now, add, if you add, what happens? Minus 7 plus 7, 0, 0 plus 0 is 0, again 0 plus 0 is 7, minus 7 plus 0 is equal to 0, this is equal to 0, a null matrix. So, therefore, a square minus 5a plus 7i is equal to 0, a null matrix. This is the method to solve this problem. So, here What is the problem given? If A is equal to 3, 1, minus 1, 2, prove that A square minus 5A plus 7I is equal to 0 means just find out A square is equal to A into A. So to same matrix multiply. So you will get 8, 5 minus 5, 3. Again substitute in this given equation A square minus 5A plus 7I. A square minus 5 into A plus 7 into 1, 0, 0, 1. Multiply this, 5 is a 15, 5 ones are 5, 5 ones are 5, 5 twos are 10, 7 into 1 is 7, 0, 0, 7. Subtract these two, 8 minus 15 is minus 7, 5 minus 5 is 0, minus 5 minus into minus is plus 0, 3 minus 10 is equal to minus 7, plus 7, 0, 0, 7. Add minus 7 plus 7 is 0, 0, 0, minus 7 plus 7, 0. So therefore, A square minus 5A plus 7I is equal to 0 is a null matrix. This is the actual problem. Okay. Now suppose if the same question is like this, I will do the same question with different given conditions. If I remove this, no, I don't want this. Given, if A is equal to 3, 1, minus 1, 2, given that A satisfies A square minus 5A plus 7I is equal to 0, where I is an identity matrix of same order, find A inverse. Actually, we did this type of problems in the previous class. So here, if A is equal to 3, 1, minus 1, 2, given that A satisfies the equation A square minus 5A plus 7I is equal to 0, where I is an identity matrix of same order, then find A inverse. For this, the method is different. So the given condition, it is satisfied already. Given condition, given equation is, what is the given equation? A square minus 5A plus 7I is equal to 0. This is given condition. Now multiply by A inverse, pre-multiplication by A inverse. A inverse into A square minus 5 A inverse into A plus 7 A inverse into I is equal to 0. Now A inverse into A square can be written as A into A. This is same, A inverse into A plus 7 into A inverse into I is equal to 0. Using associative property, interchange the bracket. This can also be written as A inverse into A minus 5 times A inverse into A plus 7 times A inverse into I is equal to 0. Now since you know all these properties, just recall the properties. Since A into I, that we did, I into A is equal to same matrix, that or A inverse into I, or I into A inverse is equal to A inverse, or A inverse is equal to an identity matrix. Using these properties, now what is A inverse? This is I into A minus 5 into, what is A inverse? This is equal to I plus 7 into, what is A inverse into I? That is equal to A inverse is equal to 0. Now what is I into A? I into A is equal to A minus 5I plus 7 times A inverse is equal to 0. Now what is required to find is 7 A inverse, keep here itself, and transpose minus 5I becomes plus 5I and plus A becomes minus A. This is 5 into I is 1, 0, 0, 1 minus A. What is a given matrix? 3, 1, minus 1 and 2. Simplify this. 5 ones are 5, 0, 0, 5 minus 3, 1, minus 1, 2. So multiply. 5 into 1 is 5, 0, 0, 5. This is same. Now this is 7 A inverse is equal to 5 minus 3 is 2. 0 minus 1 is minus 1. This is minus 1. 0 minus into minus is plus 1. 5 minus 2 is 3. So therefore, the matrix A inverse is equal to 1 over 7 times and 1 over 7 into 2 minus 1, 1 and 3. This is the inverse. So 2, 3, minus 1 and plus 1. So the inverse for this matrix is 1 by 7, 2 times minus 1, 1 and 3. So this is the other method. First method is verifying the given equation. Second method is finding the value of A inverse. So in these two type of matrices, in these two type of problems, you may get one question for your final examination for 4 marks. That is in part E, 6 plus 4 marks. So Now, that's regarding today's section. That is regarding the first chapter. Thank you.